My name is Boldizsár Német, and today I'm presenting a refactoring tool or a framework for Haskell that I'm working this year. Now, I think I don't have to talk about how great language is Haskell, so I'm just skipping this slide and jump straight to the refactoring part. Now, as you know, refactoring is a code transformation that does not change the semantics of the code. And there are several ways to perform refactorings. Now, it's a somewhat traditional way to do it, to directly rewrite the token sequences. It's natural that it has a high performance because of the direct manipulation of the textual data or tokens, but it lacks the abstraction levels. So I have to specify the transformation on the level of tokens or text. Now, there are other ways. For example, the third point is here that I'm concerned about is to define the transformations on the AST or abstract syntax tree of the program and somehow solve all the problems that arise from this approach. Mainly, the AST does not store information that is not relevant for the compilation. For example, commands and layout of the source code. So somehow it is a task to remember this data and to do the transformation that keeps this data. Otherwise, it is unusable if I ever rename a function and all the command information and layout is lost in the file, then it is an unusable refactor tool. So somehow we have to store this information in the AST. And I used an architecture that relies on GHC. Namely, I used the internal AST representation from GHC and convert it to another representation, mine representation, that also stores layout and semantical informations in the AST. And after refactoring this representation, a simple pretty print operation can restore the code in the original form with the modifications that are performed by the refactoring tool. Now, this is basically what I talk about. We use the GHC compiler as a backend because it's the most up-to-date compiler there is, and we can convert this representation to something that is much more usable for rewriting, because as I think GHC's representation is geared towards compilation, and it's not really meant to changed and pretty printed, but instead it is meant to go on with the compilation and generate simpler representations and code from it. So I created a different representation that is more suited to refactoring. It is also used to store these informations that is related to the original form of the source code and the semantic information that is not directly stored in the AST. For example, in the AST, there might be a lot of definitions with the name A, but I can attach semantic data to distinguish between several functions that are named A, for example. and this semantic information can be obtained from the GHC. Now let's go and talk about the source information we are keeping, because I think that's the only unique idea in this method. Here we can see how source information is transformed into several different stages. At the end, we will be ready to pretty print this. And at the beginning, we only have the source ranges of the different AST elements. That is the source information that we can acquire from the GHC EST. Now we have these source ranges for a simple expression of 1 plus x. And we convert that to a so-called template that is basically the ranges, but the child elements in the EST are cut out from the parent elements and are replaced with placeholders. This is important because if we change the child elements, then the printed results should change accordingly. So there should be some placeholder for a child element in the parent element. And after that, we basically read the source file and replace these ranges with the text that are on that range. Actually, we don't have to read it again from the file, because GHC stores the buffer in the session, so it's a bit faster to use GHC's internal buffer for that thing. But basically, we get the text from the source file and we replace the ranges with the according text. And this is the final representation, because as you see, it can simply pretty printed in a recursive fashion, in a top-down fashion by pretty printing these texts, and if we encounter a placeholder for a child, then we pretty print the according child. So it's very simple to pretty print that representation. And if I change something, for example, I rename the variable x for y, then the source code will change accordingly, because it replaces that child with another child with the according source information, and it will transform the program as expected. Now, our goal is to support the writing of refactorings, and the whole infrastructure is geared toward to be able to easily write refactorings in a few hundred lines of code. And there are a lot of features for helping. For example, this thing that we combine all the necessary informations into a single representation that is suited for transformation, and we have those semantic informations and a lot of helping libraries. We have lens-like property abstraction. We can use Uniplate, and we have some traversals on the source, on the abstract syntax tree. So basically, the whole framework is for easily writing refactorings. Now, let's see how far we've got in this half a year. We fully support the latest Haskell platform. We have 5 merely complex refactorings that are implemented, and we created that framework to store and keep all formatting and comments, and we created this framework to be layout sensitive, because there are some occasions when while refactoring we have to check that we don't mess up with the indentation of the program elements, because that we know that it can change the semantic in Haskell. Now let's see what refactorings are implemented. This is 5 moderately simple refactorings. Extract binding can transform a sub-expression into a local binding. So complex expressions can be broken up into sub-expressions. Rename, as it is very trivial, it renames a definition. That definition can be anything, more like anything. It can be a function, a type variable, a data constructor, or just name something. It currently can't be a module, but all other things can be renamed. There is a refactoring to generate the type signature of a function, because it's a typical use case for me that I just write a short function, then I just think that I have to put the type, but it's a bit tricky to figure out the exact type of that binding, so I'm just asking the compiler to type it and just generate that type for me. And we have a refactoring for organizing imports for a module and getting rid of duplicates and sorting them in order. And we can generate exports for all definitions that are defined in a given module. So these are the refactorings that are currently implemented. And our future plans include getting editor support and having a wider variety of refactorings. Now I have a few students working on subtasks of this, and hopefully next year we will have something to have a demo with a live editor that supports these refactorings. Now, we have a lot of plans, but I'm not going into details because I think we have to be quick. And now let's see the demo. That will be the surprise. Now, I'm here. It is readable? This font size is readable? Okay. Then this is the official website, but it's from localhost now. But it's haskelltools.org. And I'll just show maybe this example. Here on the website there is a live editor where you can try out these refactorings. So I don't remember what I did for that animated GIF, but now let's see, generate the signature for this definition. I'm not using the key bindings because you can't see what keys I'm using, and here are the buttons to do the same. So I can generate this type signature here, and another exciting thing, I think, to generate a local binding from this. Guess something, maybe it's not divisible, because it will be true if x is not divisible by p. So here it is. It's an inner local definition, and it's using x. So I think that's my time for now, and well, all contributions are welcome for this project, and well, check out. Thank you for watching. Any questions? Yes?
Can I ask, like, if you already have like concrete plans for a particular editor which you want to extend? You mentioned that you want to.
Yes. So the question was if I have any actual plans for which editor to integrate with, and yes, actually my students has the task to evaluate which editor would be suitable for this, but I think that one of the candidates is Sublime Text, because it's written in Python and that student wants to be a good Python programmer, so it's a good task for him. But well, I think it depends on how much contribution we can get. I'm thinking of Emacs, of course, but I haven't got a programmer who is experienced with Lisp or Emacs Lisp. Yes?
So do you plan Vim?
Well, I'm not an expert with Vim, so.
Who is?
Well, if someone who is expert with Vim would like to contribute for the project and help with the integration, then I would be glad to have Vim integration, of course.
I have one more question. You showed that you are extending the AST from the GHC, and my question is if the AST between the versions is stable, or if it changes and if it doesn't break your implementation.
Well, now, so the question is if our AST is different from the GHC EST, does it cause some problems if there is a version change? And now I have live experience of that, because 1 or 2 months ago I've changed from GHC 7.8 I think to 8.0, and well, there had been some changes, but these did not affect our representation much. So maybe it was a few days, and it was a major version change. So I'm not anxious about that. Any more questions?
Do you support multiple modules?
No, that's the next milestone to that. So, thank you for your attention again.
There is one more question.
Yes?
So, recommendation. So I haven't seen the first part of the talk, but what if you don't work directly with syntax as displayed in the editor, but instead display some sort of a reduced version of whatever EST is there in the background, and store information there in the background. What I'm getting at is that you could have a lot of modules imported with different versions of, say, the mat function, and it would be preferable if the user could always see a simple, simple non-prefix version of mat, every time he uses it, but internally it would be referencing some specific unambiguous version of map, such as array.net or prelude.net. And what you should do for that is that whenever some part of the program is copied onto the clipboard, it should be in a format that will could be analyzable in another part of the editor to resolve various ambiguities.
One of my friends is thinking about something like that. He thinks about writing refactorings for domain-specific language. And I think that's a bit similar to your idea of higher abstraction level. And for that, some kind of alternative representation or an alternative interface to the AST representation have to be established to work on a higher level, to write the refactorings on a higher level. So yes, we have some research-oriented plans for something like this.
So thank you again, and we will have the next lightning talk. Thanks. Vagy kösz.